Okay, so for this next example, same thing. We'll plug in 4, try, and notice that we get 0 over 0, which is indeterminate form. But now we're feeling a little happier because we know what to do. We know what to do some algebra. Now, maybe not so happy because this is a new case. Not quite sure what to do yet, but can you think of a little algebra to do? Well, first thing that comes to my mind is to try some rationalizing. So you'll remember to rationalize something like this, you would multiply by 2 plus square root of x, top and bottom, which would give you the limit as x approaches 4. Notice on the bottom, when you FOIL this all out, you would get, since this is a difference of squares, you would get 4 minus x. Now on top, notice that I'm not going to distribute that through because you'll notice that if you distribute it through, actually you would make a bigger mess for yourself. But if you don't distribute it, notice that these guys right here are the same and just cancel. So then what you can do is you can plug in your value 4, and you would get 2 plus the square root of 4, which is just equal to 4. And that's it. So let's try another one. This is a different type of indeterminate form, because notice that when you plug in 0, what you get is 1 over 0, which is basically infinity, and then minus infinity. Now this doesn't necessarily mean 0, because although they're both going to infinity, you don't know how fast they're going to infinity. And I'll show you an example later of what I mean by that, but this is still indeterminate form. So we need to do some more work here. So for these, what's the first algebra that comes to mind? Well, to me, I think, well, why don't we combine them, see what happens. So before you combine them, though, let me erase this guy, these little zeros here. Before we combine them, let me start by factoring this guy into x times x plus 1. So then I would only need to multiply this guy by x plus 1, this guy by x plus 1, and then on top I would get x plus 1 minus 1 over x times x plus 1. And so notice that 1 minus 1, those guys cancel. And now that x is the only thing left over on top, well, those two, I can divide them. And if I plug in 0 now, I get on top, I have 1 over 0 plus 1, which is 1. So the limit of this guy is simply equal to 1. Okay, so in this problem, let's try our usual plugging in 0. So notice that on top you get 3 to the negative 1 minus 3 to the negative 1, which is 0 over 0. So this is indeterminate form. Okay, so we've got to do some more work. Now, these guys, these look a little funny. So what I want to do, I think, is to get rid of the exponents. And so to get rid of the exponents, you have to turn these into fractions. Now you have to be careful. Because you're subtracting, you can't simply move these to the bottom. That's only if they were multiplying. But what you can do is rewrite this as 1 over 3 plus h, and then minus 1 over 3. So what you did is you turned these into a fraction, and thereby making the exponents positive. and all over h. Okay, then you can combine them. So we would multiply both sides by 3, top and bottom by 3, this one by 3 plus h. And we would get that this is equal to the limit as h approaches 0 of, on top we would have a fraction with 3 times 3 plus h on the bottom, and we would have 3 minus 3, I'm not going to put the parentheses, minus h. So make sure that you know you're distributing that negative sign through. So the before I do that, okay, sorry. All right, and then all of this is divided by h, and I'm just going to put this as h over 1. Okay, now the 3's, of course, you subtract them, and then here you would bring this guy over as, so you would invert and multiply, so you would bring it over as 1 over h. And so then what happens, of course, is the negative h and the h divide. And so what you're left with is that this is equal to the limit as h approaches 0. On top, you're just left with a negative 1, and then over 3 times 3 plus h. And so notice now that if you plug in 0 in for this guy, you're just left with negative 1 over 3 times 3, which is 9. And that's it.